Microphone check. What's up, everybody? Analytics Arcade here, also known as Data Cultivator on YouTube. Just jumping online to introduce myself and share some programming with you guys. Hoping you guys could follow along, ask questions, you know, make this a learning experience. And please feel free to comment. Uh, Thanks, Bach. Thanks, Beans. I appreciate it. I think you appreciate you guys jumping in and saying what's up. So, if you guys want to follow along, you'll need to make sure you guys have VS Code, Python installed. If anybody has any requests to show you how to install that, I'd be happy to do it. But let's just go ahead and get started. All right. So here's our live show. So I've already programmed this before. This is just something that I program for fun. I like astronomy, so I downloaded this so I can have my backgrounds, uh, background images on Windows to just kind of show. So that was the original idea behind it. And then after that, uh, you know, you can kind of do whatever you want with it. So these are the libraries we're going to use. Request pandas, there's a built-in OS, datetime, IPython display image, and parameters. So the parameters is something that I wrote, and basically, if anybody's interested in following along, they're going to want to go to this link, right, and get their own API key, and it's super easy. It's free. All you have to do is click on get started, sign up, basically throw in an optional how you're going to use it if you want, and basically you can use it 1,000 requests per hour. So you have a hourly limit of 30 requests per IP per hour, and a daily limit of 50 requests per day. Uh, but I haven't ran into any issues, and just a few minutes ago I went ahead and downloaded basically all the images for this year. And let's see if I can show some examples of that. I have it here in this demo folder. And so, again, you just go in there and it downloads. This particular case is just a standard definition, but what you see in the intro video is actually the high definition version of those. So, and cool things you can do with it and Python, for example, that's how I was able to create this streaming my basically streaming soon video directly from the images and libraries directly in Python. So the way you get started is, you know, just to show you guys, you know, from scratch. Basically, what we're going to do is we're going to use these APOD APIs, which are basically GET calls that you can call and pass in query parameters and get results. And for example, you can look at this example, and when you call that API, it sends over the text and a link to the image itself. So what we're going to have to do is make a call per day, and then from there we're going to go ahead and store the data, and then make another call to pull the image. It's a pretty straightforward process. Again, I've already done it once or twice, so it should be pretty straightforward. And if I run into any issues, I'll just refer to my book. And actually, I think I have that here in my demo one. And this is basically the key. I think I actually have a newer version than this, but it's pretty basic stuff. So let's just go ahead and start from scratch. So let's start by getting the URL that we're going to need. Paste that in here. All right. Let me pull up my comments. See, I'm not missing anything. I need to figure out a better way to look at the comments with you guys. Again, you have to bear with me, guys. This is my first stream. Again, I appreciate everybody for popping in and bearing with my growing pains. Yeah, bro, I can teach you how to hack. It's one of the things a data scientist does, but I won't teach you anything unethical, I'm sure. But hacking's a broad term. All right, it looks like I can see the text now. Okay, bear with me. There's the company video I wanted to pop open. There was one other one that I wanted to pop open too. Bear with me, guys. Yeah. All right. This guy. All right, so let's make a plan. It's always the first thing you want to do when you're starting a project, and since we're showing this from scratch, we want to show you guys how to do it all, right? So you have your URL, right? And what are we going to need? We're gonna download data from this API, so we're going to need inputs for that. So let's go look back at the inputs. Here we go. So let's just take a screenshot of this. Nice, basically document it at the same time. All right, so it looks like we're going to need a date, and we're going to need, so you can actually pull from a range, but we're going to just use the date parameter. And count is, so basically you can go over these. It's a specific count, randomly chosen images will be returned. So if you want a certain number of images between a certain date, that's when you'd use that. And I didn't use this in the example, but we could probably use it. So some of the videos, some of the images that you try to pull are actually videos, and it's just like a link to YouTube. But if you put thumbs equals true, it'll send you um, an image of basically the front page of that YouTube video. So it's not as handy. It doesn't look as good. So I'm just gonna leave that alone for now. All right. So let's go. We're gonna create a few variables. So you'll see that some of this stuff tries to get auto-filled, and that's because I have Copilot enabled. But I use it sometimes, so I'll leave it enabled, but it's not necessary. So we're gonna choose a start date of January 1st and the end date of basically now equals date time that now. And when we run that and we print our variables, See how handy that was? It just detected what I wanted to print next. I guess I'll ask a question. If can you guys see the screen very well? I'm not sure how visible it is, but if we need it to be a little bit larger, you know, I definitely can do that. So let's leave it for like that for now. If anybody has a trouble seeing, please say something. If not, I'm gonna assume you guys can see it. All right. So I'm a data scientist, and there's plenty of ways to do what I'm doing here. But I like to use pandas. It's a pretty handy tool. So you'll notice that we already imported it, and this will be the first time we use it. So what we're going to do is we're going to create a date range, right? And when are we going to start? At the start date, and we're going to end at the end date. And this will give us something, right? It is set for frequency of days, but I like to be explicit and make sure you tell it to use a frequency of days. So that way, in case it ever changes, you want to make sure that that'll let you do that. And I'm gonna go ahead and use this, and basically what that's gonna do, it's gonna reverse it. Again, there's plenty of ways to do that, but if you notice, it's gonna pull the first day front. Uh, the 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 most recent date is gonna go first. But again, that really doesn't matter. But we're gonna end up calling this date range. All right, let's look what that is. There we go. So it's that date time index that we can use. Now let's, before, eventually this is going to be a function, but let's not worry about making it a function for now. Let's just go ahead and just write the function, right? So what we're going to do is we're going to use the request library, and we're going to use a get function. We're going to pass in the URL. We're going to pass in the parameters, and I don't want that. Okay, I forgot to store the response as a variable. We definitely want to do that. So there we got response 200. Uh, I don't know if you guys are familiar with APIs, but response to 200 basically means success. And not all of them are the same, but it's pretty standard that's a success response. So let's take that response and now convert it to a JSON so we can look at what we're dealing with here. So every time that we do a GET request to this API, we end up with this response that I was telling you about. And from that response, we can say RSP JSON equals this. We can take that, and voila, it's now stored in a variable. Um, but since we're trying to download all of these, it only makes sense to put this stuff in a loop, right? So the way, a simple way to do a loop in Python is, for D in date range, and let's just go see what that looks like. See, it went ahead and printed out that date. I don't want to pass in this time into the date because it's not being asked for. And when you pass in things to an API when they're not asked for, you typically will get an error. So let's let's figure out a way to handle that, right? So off the top of my head, I think it's something from to string from time. I think that's what it is. So let's look at that. Okay, it takes one position argument. So what is that argument? So I'm pretty sure that positional argument is, let me see what the problem is here. What we need to do is provide a format for the string. So the way that works is you put the format that you want, right? So what we're dealing with here is a year, then a minus sign, and then we want a month, which is a percent lowercase m, and we want day, which is, I think it's lowercase d, and see what we got there. All right, so again, there's many ways to do that. I could have converted it to a string and then just cut the characters, but this is a more Pythonic way to do it, and you'll get the same results every time, and so it doesn't matter the order of the characters or if it's missing a zero or anything like that. It will it works better like that, right? So let's store that in a variable now, right? So we're gonna call this d date to pull. All right. So now we have that in a loop. All right. So now we need to build that URL. Okay. So let's go back to our request. So our URL, we didn't pass any parameters in, but if we're going to pass some parameters in, we need to add them to the parameters. So let's add to the parameters. We're going to add to this parameter date. And we're going to say date to pull. And then let's run that again. And as a matter of fact, let's take, just so we won't get the same result, let's take like the sixth one. So we'll just do that. And we'll call this just for development, D equals date range, and then date to pull. So that way we can kind of focus on the one we want to pull. Set the parameters up. We'll clean all this up. Let me just go ahead and do that now. This probably needs to be above. So let's look at the date to pull. And I can't really show you my parameters because it has my key in it. But this is basically, I saved a file called params.py, and I created a new dictionary, called it params, and then I put a key inside of it of API underscore key, and then I paste it in my API key that you received via the email. So once I add the date to the parameters, then I can try to pull that. And let's look what that response looks like. Make sure, get rid of this. So we had 5:30 before, now it's 5:25. See, perfect. So we're able to add that date to pull into the response. So now that this is working, we don't need, it's part of the loop. So what do we do with those responses? Well, a lot of times when I'm just collecting data, I just create a list, I call it data, and then I append the response to that. And since, let's just put the response in like that. And let's run that. So that's going to pull the data itself. No images yet, but again, that'll give us basically everything we need to pull all of that. Let me see. All right, let's see if I can raise the volume on my mic. All right, there you go. Let me see, and take your shirt and take off your shirt. I'm trying to see something. You want to see my muscles? We'll have to not do that right now. Not on my first stream, anyways. Oh, thanks for that, Beans. All right, so that's it. Just in a few seconds, we were able to download all the data. Voila. So again, from API, simple request, simple Python. This is pretty standard. Most websites have APIs, believe it or not. All right. Now, what can we do with that? We're going to now want to take this list of dictionaries and make it a pandas data frame. And that's as simple as passing it in. And So let's call this APOD data frame. And I love data frames. Data frames are cool. You can do things like look at the head. You can do things like data APOD. Let's, what else can we do? We can do we can sample it. Say we want to sample 10. So it gives us a random sample of 10 of those samples. And if you pull more than the number of rows in the samples, it, okay, now that I've made myself louder, I hear myself louder, so it's super annoying. I need to figure out how to fix that. Together, let me see. I think that's just gonna be a Microsoft volume mixer. I think we could turn OBS down here somewhere. Hmm. Maybe I'll just turn it down that way. Okay, I don't think that affected the way you guys hear me, but I'm not listening to any music or anything, so that's no big deal. Microphone check. All right. So, again, there is actually a way to pull the same samples twice, but you need to just tell it replace true, and then it gives you, it just resamples the same sample, so you can have you can have duplicates. So usually that's not very applicable for most things. So, you know, like if we wanted to check a random 50 of them, we were able to do that real simply. And I think another one of my favorite parts of data frames is how easy it is to write it out to a file, right? APOD data frame. And that is how easy it is to write to a file. And you can import it into Excel. I know that's a lot of people's favorite tools, and so there's lots of different things you can do to it from there. And if we go back to that right here, APOD data frame, and we say to underscore, you'll see that there's so many different things you can print it out to. You can print it out to Markdown if you want it for, oh, what's it gonna mean about? Okay, well, I need to start install a new library for that, but nonetheless, it will work if you spend some time getting that to work. Another one I use a lot is to HTML. If you want to put that on a website, or if you want to actually make an HTML document out of it, you can just say APOD. I'm pretty sure it would need to be wrapped, but nonetheless, pandas data frames are amazing because all the different things you can do with them. Makes life easy for a data scientist. Okay, so now that we were able to fetch the data themselves. Now we need to fetch the image itself. And believe it or not, it's pretty similar to that. Let's go ahead and get started on that. So now that we have this in the data frame, and we can do loops through it as well, right? So we can say for IDX and row in iter rows, and let's just pass for now so everybody can see what is in IDX. So basically, IDX is the last IDX in this loop. So basically, there's 150 IDXs in there. It's the last row. And let's look at the last row. All right. So that way, if we want to access any of these variables, all we need to do is pass in the key, right? So let's pull in one of these so I can show you an example. Now that we click on that, voila, full size image. All right. But who has time to click? Right click, save. That would drive me insane. Um, so let's use that URL. Now they give us a full URL. So let's, again, we don't want to do it in the loop right away. Let's work on one row at a time, and then we'll add it to the loop. So let's say HD URL. Make sure I got the right thing. Voila. Okay. So let's go URL equals that. And again, we're going to do just another get. So let's see if we can get, let's see, we're going to go ahead and keep the parameters. I don't think the parameters are required. So let's not use them now. And while we're testing anyways. So, if I'm not mistaken, that's all we need to do. All right, we have a response. Response 200. That's a good sign. So this is going to need to be written out, right? So let's. I think we need to write out the contents. So what we need to do is say with open, and then let's go test JPEG. Let's see, response.content. Hey, see, it pretty much wrote it for us. And I called it text.jpg, whatever. Aha, see, that's simple. So now all we need to do is figure out what are we going to call each one in the loop, because this is basically the loop that we need to make that work. All right, so as long as we get our row, get our URL, we can loop. Now all we're missing is our file name. All right, so let's look at what's in the response, and I think text is something, or we could use something that's in the row. Let's see what we have in the row that we can use for our file name. Run that real quick. Is my outputs closed? Let's keep waiting. Okay, there we go. I don't know what that was, but it was trying to take that image and print out all the text. So that was what went crazy there. So that's not what we wanted. So let's look at a URL, see if there's a name we can get off of that. Let's just use the name that they provide, right? So let's split it. I don't even remember if this is the way I did it, but I don't think it is. But it's pretty straightforward. What I'm doing is I'm taking that URL, then I'm splitting it based on these right forward slashes, and then I'm pulling the last one. So we can call that file name equals that, and add that to our loop, our pseudo loop. And actually, we don't want to retype that. Not that that matters. Oh, I forgot to put file name. Okay, let's go ahead and interrupt that. Just save the API calls. Let's get rid of this demo. Ah, there it is. Voila. All right, see? So, again, just a few lines of code. We're able to do that. And, and although I do have the answer next to me, this is all simple stuff, right? And I don't always have the answer next to me. I just did it so I could be prepared for my first stream. And but it's pretty straightforward stuff, right? All right. Now that we have a good test, what do we want to do? Is, well, one thing is we don't want to write it in this file, all right? So let's use the OS and join a path to it. So let's go ahead in our Analytics Arcade. No, we wanted to create a new folder. Let's call it HD images. Right, it's in the same HD images. Alright, so we go os.path.join. Let me pull back up my stream just in case I got any questions. Alright, no questions. So what are we gonna join? So we know the path is HD images, and we know, what do we have? A file name. So let's pass HD images and file name. Voila. So we're not gonna programmatically create the HD images folder, but that's okay. We can do that another time. So we need to add this to our. All right. And since we don't want to run it on everything at once before we test it, let's go ahead and comment this out. We'll hit a pass here and then just run it on the last one. Oh, that is the same. That may be right. That may be right. I may have been pulling the last one each time. So let's, instead of pulling it on ours for the first test, let's use our fancy sample and pull the first 10. All right. We'll call this sample data frame, and we'll pull, excuse me. Four viewers on my first stream, guys. I appreciate it. Thanks for stopping by. Super excited. I've been debating whether I wanted to do this for a really long time, but you know, I love data science. I love teaching, so it only made sense. I will say thanks to a special friend over there who kind of pushed me in the right direction. You know, so looks like it's working great. Look at that. So real quickly, with just a few lines of code, let's see. Oh, no URL. So I'm glad I saved this sample data frame so we can take a look at what that. An image with no HD URL. Great. So many ways to handle that. I could filter them out. Let's see. We're gonna say HD URL. That is an A. Oh. There's that bad boy. So let's just create a mask out of that. And then we will take that mask. I always wonder if I need to put my tilde here. So that way, I want it to be true, so it processes those, and then false, so it doesn't process those. I mean, there's multiple ways to do that. I always hesitate. I call this a mask, and usually that means you mask out the stuff that you don't want. So I typically put the tilde here. But if I put the sample data frame here and pass in my mask, you'll notice that we no longer have that NaN value there, right? That's a simple way to do it. Another way to do it is to leave it there and then tilde your mask. Uh, to, to me, that's one way of doing it, and it works. But is it readable? To me, this makes more sense. So now that we have the masked sample, we can rerun that. But since we ran to that masked sample, which was the 24th, it's no big deal. Let's just delete these and rerun it. There's, instead of checking if they're there. It's just 10. This is just a test. Okay, let's. Uh, every time I run this, it gets a new sample, and so just to show the concept of being able to mask that out. All right. Well, I should have left them there. I would have just pulled another 9 samples. But anyways, let me get rid of that sample. Again, if you love space images, I think you'll find that these are really cool. Um, and then not only can you see these cool images, you can use them, right? I mean, they're copyrighted as long as you print the copyright on it. And I have been. So in my video, I did make sure to give everybody credit because I definitely did not create these. These are all coming from NASA's astronomy picture of the day. Okay, do we have another error? What's the deal here? No HD URLs. Did I not run it again? It went and got AM, THE, NGC, the dish. Huh, what am I missing here? Ah, I forgot to apply my math sample. Yeah, see? I was like, wait a minute. But if you notice, I was looking at the math sample, but then I was running the unmasked sample, and it was giving me an error. So this should finish this time. All right, I think I got a new image. Where's it at? Oh, that one's cool. HFG. Let's see what that one's about. HFG. Planetary Nebula. Sample 108. I think I need to put an eye lock here. Index location. Nope. There we go. And the explanation. Planetary Nebula. Hecarathon Fossen Gull. Wow. In the constellation Cassiopeia, remnants of the last phase of a medium-sized sun-sized star. In spite of the shapes, planetary nebula have nothing in common with actual planets. Yeah, see. And the cool thing about APOD is, I think it goes back 15 years. So there's so many images you can look at. And if you guys are astronomy, like astronomy at all, I think you'll find it. They have tons of good images there. Okay, so we were able to, within what, half an hour, pull basically the images from this year. And if we were to run, let's again, now that it's working, a lot of times what I'll do is I'll clear it and I'll restart it, and then I'll hit run all, and I think that would probably be okay. Let's go ahead and do that to make sure I didn't break something along the way with my moving. It also helps you test your logic, right? Test some of your logic, see how well that works. Buck, I think you'll find uh, this cool. Let me see, where did it go? I think it was in my demo folder. Yes. my coming soon script. So I think I have a newer version of this. You have to bear with me, but basically, I was able to create the intro screen with it, and I think, oh, here it is, intro screen, create intro. So this is the code I use for that. And again, it's not a whole bunch of code, and what it did is it used that CSV that I created in the previous notebook to go in and create a video. Let's just kind of go through it while it runs over here in the background. So I basically load that CSV. If I sample all of them, it just basically randomly sorts it. I resize the images to fit the screen and keep the aspect ratio good, fill in the rest black, and then I can add text to the image. And the text that I'm basically adding is stream starting soon in the middle, the copyright on the bottom left, the explanation on the bottom right with some wrapping, different size fonts and stuff. Put it to a list, and then have FFmpeg basically use my video card to write this to a file. So last time it ran, it took 1 minute and 34 seconds to create a 34-minute video. And there is some optimization to it, right? I mean, it's just like one image. So I have the frames per second really low. It's just like 1 frame per second, right? There's no need for fast. Yeah. So and then it creates, then with that few lines of Python, it's probably like an hour's worth of work for me. I'm able to create these coming soon videos with just images. So like if you had some images that you wanted to use, for whatever that may be, previous previous streams, previous scores, stuff like that, it'd be easy to take that and kind of make it fit you. And actually, I think the hard part of making this work is rebuilding FFmpeg to actually use my video card, which was kind of a pain in the ass, but it's totally worth it because when I try to write this with OpenCV, it would take so long and sometimes not finish because I'd have buffer errors. But this FFmpeg works really good, right? So, and if the hard part about that is I had to create this installation script, and you couldn't just like go double click somewhere to download and install the software. I literally had to do research on all the libraries the software needed and write this script. But I've done this many a times, but my issue is I would just basically hack my way into it. I would just kind of type words and then it'd work, and then it would work for a long time, and then I would break it somehow by installing some new dependencies or something, and then I would cry for days because I would not be able to recreate that. But if I create scripts instead of just hack, I'm able to just go in there and just like I could share this with basically another person, and they could just install WSL and Ubuntu on their computer in VS Code and off to the races. And okay, so I think that's done. So again, we're able to download all these images super fast. Again, there's not even any optimization to this. This is just basically going in there and pulling it as fast as it can. A lot of times we want to limit how quick you're pulling these things because if I was to pass, you got to think about what it's doing here. We're just basically not passing our parameter in. So the only API call that we're actually passing our parameters in is this. So as far as it's just basically going and pulling the image, no big deal. It's not actually using API calls. Da, 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 da. What else? I think that's all I really wanted to to show on the stream today. Uh, I was hoping to get some requests on other things to look at, right? I'm a data scientist, so a lot of the stuff I do is business and boring. So I figured I'd do this as kind of business, but not so boring. I don't know, not to me, anyways. Does anybody have any questions or? Let's see. Guess I could just go ahead and make functions out of these things, show everybody how to do that. So right now, you'll notice that this is it's basically procedural programming. We're just kind of going one step, one step, one step. But a lot of times it helps to define this as in functions, right? So basically, what are we gonna do? So let's pull. We're gonna define a function called pull APOD API data, and that's it. Let's just make that work. All right. So what are we gonna do? We're gonna pass in a D, and we're gonna return a response. All right, and then we can just basically cut this, paste that there, and then we can say response response equals pull data API D, and make sure I typed that right. I did not. Response. So it's a little bit easier to read, right? You can just go in there and you say, this is the loop, right, for D and date range. The response equals the pull API data. That function is kind of put together so it's easier to deal with. And if you notice, that works pretty much the same. Let's see what it's complaining about here. Ah, it is request JSON. Oh, so our first error. Great. Errors are gonna happen when you learning to code or even just building something new, right? You just run into errors all the time, right? So let's see what it's trying to do here. Let's see. First thing to do is check the input. What's D? D is a timestamp, right? So let's see where it got to. Append JSON.data. So we did get something. So it made it all the way through the function without crashing. So now let's just look at what that response actually is, since that's outside the response 200. So what's the deal with not being able to convert it to JSON? Ah, start date and table date. What did I do wrong here? So we're getting the URL. I know what happened, and this happens sometimes too when I'm running stuff out of order, right? You see this URL? It's still the URL from way down here, right? So I wouldn't be running this into this problem if I just like started from the top. See URL. So now it's just one of those things that you run into if you kind of run your cells out of order, and that's why right, it's important to go ahead and restart and rerun your notebook sometimes, right? So you can be positive that you're pulling the right stuff. So another way to handle that is to call it a different variable name, right? This is the base URL, right? Which probably makes more sense to call it that anyways. So that way, I did run in that order, that shouldn't be an issue. So that works. All right. We don't need that. We can probably not do samples anymore if you guys wanted. And just run the whole darn thing. All right. So that worked. There's our data. All that wonderful data. Oh, I just thought of another thing that I really love about pandas data frames, guys. So I don't know, but it'll make sense on this data frame. I figured out a way we can. So we're gonna take the explanations and we're gonna say to list. Come on, computer. All right, so I took all the explanations, I converted that to a list, and now let's join those to one large string of text. All right, now we have one long string of text, so we're going to call this a pandas series. And we're going to call this, no. Okay, we got that. Okay, now this is the explanations. Right, we got our explanations. Okay, and what I wanted to do there is we're going to split it on spaces. All right, and now we're going to say this is our split XPs. And then let's take that and put it into a series. I know, there it is, value counts. So value counts, there was not really a kind of a use for it in the data frame altogether, but sometimes there is. And when I say PD series, PD.series, so series, a data frame is basically a bunch of series that basically have the same number of rows and they're kind of put together. So if I was to say APOD, pick the HD URL, I can say APOD HD URL, and it's basically a panda series, right? And but the point I'm trying to make is this value counts is super handy, and you can do things like histogram plots, matplotlib. Oh, you know what? I created this environment and I totally didn't put matplotlib in it. That's so again, I'm using pip to install my packages. Matplotlib. And voila, should get rid of that problem. Voila. Yeah, well, this kind of doesn't make sense, but a histogram where you take the words and put them along the bottom, and then you can see the frequency of the words and stuff. It's a little bit more code than just writing .hist, but the data is really what you're trying to get out of it, and so in all the explanations, the was used 1,746 times of the. And again, if we were doing some NLP, there's a lot. These are called like stop words. Like we can get rid of all those. And as a matter of fact, I can pull up some word cloud code. Alright, so I know I have a word cloud in here somewhere, but I'm pretty sure there's just a library that I can just like throw these value counts into, and it will do a word cloud for us because we could write it from scratch, but why would we can use a library? You know, when I first started programming, I hesitated. Oh, I don't want to build a library. I mean, I don't want to use other people's libraries. I can do it myself. I can do it myself. I can do it myself, which led me to learning a lot of Python. But at the same time, there's so many different ways to do things. When you look at a library, a lot of times, you know, they have a lot of practice doing it, right? So let's just pip install word cloud. Voila. And it is as simple as running this code right here. Voila. And again, there's a good word cloud. I would have gotten rid of these funky words. Uh, I know there's a way to do it. But let's kind of look at this APOD used a bunch: light, corona, Milky Way, near dark, kilometers, Earth, constellation, thorough. It'll look much better once we remove those stop words. And let's see if I can do that real quick. Word cloud has stop words. Yeah, we can filter those right out. Filter words. Now let's look at the differences. You know what? I'm sure my stream would be better with music. Maybe I'll make sure I get music set up next time. And now we got our better words. There we go. See? Sun, image, visible, stars, solar, features, planets, dust, cosmos. Yeah, this is a much better word cloud. Um, so again, just using the data. All right, folks, I think that's all I wanted to show you today. I'm going to go ahead and end the stream. Uh, I appreciate you stopping by. Um, and again, this is my first time streaming, so I'm hoping to have some little bit more excitement and maybe some cooler things to work on. But feel free to suggest stuff, and we could just go from there. Bye, folks.